But now let's continue with Andreas Tesch from the European Space Agency, and he will present some spin-in potentials that ESA has identified. Andreas, the floor is yours. I will let you share your screen.
Can you hear me good like this, or? Good morning. Good morning, ladies and gentlemen. I hope you can hear me well.
Yeah.
Yes, all great.
Oh, I can't hear anything. Sorry. Can everybody hear me well?
Yes.
Okay, great. So welcome, ladies and gentlemen. I want to give you a small introduction in our technology roadmap, and then focus on really spin-in activities, spin-in ideas that we generated. My name is Andreas Tesch. I'm from the Materials and Processes section, and I will use the slides of my colleague Susanne from the commercialization office to present a little bit the technology or the background, and then the slides from my colleague Advenit Makaya, also from Materials and Processes, when we go into the ideas for spin-in activities. So what is the objective? Of course, the objective is to raise the awareness about the potential benefits of spin-in activities for ESA and the whole industry. Outline strategic framework for fostering spin-in within the agency and also within the member states. Then, of course, generate interest to support the potential spin-in activities and improve the market and demand and supply for space industry. Within this scope, we will focus on strategic aspects in fostering spin-in rather than developing or delving in specific details, technology details. We want to build up a strong community around spin-in, to foster open communication and broadcast information. And of course, we want this one scope is also to increase the collaboration between the ESA departments and the industry, academia, to establish a strong cooperation to drive spin-in innovation, and to utilize the network of technology brokers to bridge this gap between space and other industries, as well as the ESA technology needs. Talking about the needs, maybe one quick overview on technology harmonization. So we have a technology harmonization advisory group where you can also participate. If you want to join, please send an email to hamo@esa.int. What is it doing? It's basically mapping the technical status, competition, mission needs, products, market, strategic interests, funding, organizations, and competencies. And then from this, we are building roadmaps, and we have several roadmaps for special technologies, a lot on materials. So, for example, composite materials is one roadmap. We have also a roadmap on advanced manufacturing and many more. So if you want to have a look at the website to get more into the details of where we're interested in going, and where we have already a plan to go in which activities you can maybe participate. We are basically separating our technologies in different competence domains. We have 10 competence domains. The first one is on EEE components, photonic, and MEMS. The second one, where I'm more focused, is on structures, mechanisms, materials, and thermal. Then we have another one for avionics systems, electric architecture, power and energy, radio frequency and optical systems and products. The sixth one is life and physical science, payloads, life support, robotics, automatization. That's more linked to ISS applications, but also to science, robotics, exploration activities. Then the seventh one is the typical launcher competence domain, which is on propulsion, space transportation, and also very much strongly focusing now on re-entry vehicles. Then we have ground systems and mission operations. As a ninth one, we have digital engineering, which is, as you can imagine now with artificial intelligence and KI, very much on focus at the moment. And then we have the 10th one is this astrodynamics and space debris, space environment, also very much on the focus now, because there we have always the problems that the optimal, let's say, optimal orbits around Earth are getting more and more, let's say, filled, not polluted, but filled, but also polluted. And we have to think about how we can get rid of the space debris so that the satellites we want to have there are not in danger of getting damaged. All this is also focused in the European Space Technology Master Plan, which is generated every 4 years. The latest one is 2023. Again, here, if you want to have a copy of that, please have a look or send an email to estmp@esa.int. And there you will see technologies we developed already and where we want to go. The roadmaps will be there as well, where we want to go in the future and where we are focusing on. For the next year, or next 2 years, we generated some focus technologies based on, of course, the ESA technology needs, the business valuations, and also the industry demands. And so in 2025, 2026, we will focus very much on enabling artificial intelligence for space system applications. We will look at micro and nanotechnologies for radio frequency, optical systems, and pressure sensors. We are very much focused on onboard computers, data handling systems, and microelectronics. This is, I think, an ongoing topic which we always have and where we always have to improve. Avionics embedded systems, technologies for hold down and release mechanisms and deployment mechanisms. Then, of course, the big group of advanced manufacturing, deorbiting technologies, PCBs and electronic assembly technologies, and then the power radio frequency measurements and modeling, and all the systems, let's say, about generating the energy in space with solar arrays, solar generators, and solar cells. A very hot topic as well, also electric propulsion systems. They are very, very strong and advancing more and more into our spacecrafts. And actuators, building blocks for mechanisms. With this, I want to close basically the technical thing or technology overview and go to the advanced additive manufacturing and the challenges that we see for space hardware, and where we thought about from our side what could be interesting for non-space industry for spin into space industry in terms of technology. And this I want to go a little bit more in detail with you. So one thing is, of course, one challenge that we have is the manufacturing costs. So reduce the costs and the lead times for space electronics hardware, in this case, to support trends towards larger series and commercial spacecrafts. Here we see the potential to introduce state-of-the-art commercial technologies from non-space electronic materials, like, let's say, from the consumer good industry, from the automotive industry, mobile telecommunication, and of course, also a potential for technological areas would be, in this case, lead-free assembly, printed circuit board technologies. That's some ideas that we came up. Of course, if you have any additional ideas, you're always welcome to feed them in as well. Another thing, another challenge that we always have is to improve the reliability and efficiency of inspection methods for electronic assemblies and enhance the operators' training practices. Here we thought about the spin-off opportunities, potential from augmented reality, virtual reality industry, and from industrial production sector, where it's more already using these virtual reality, augmented reality systems for the training and to increase the reliability and efficiency for our inspections. Then another point is to achieve larger series and lower costs for space hardware. I mean, here we're also talking about new space, where we want to have maybe more satellite constellations. There's definitely a lack of knowledge in the space industry, where we are used to produce a few satellites and then we develop a new satellite. So I think there's a huge potential to introduce know-how in production methods from large series production sectors like automotive, consumer goods, and we are definitely looking forward to ideas there how we can feed this into space industry, space business. Another one where we also having quite a challenge is to reduce the cost and lead time for non-destructive inspections, especially again when we look at large series of spacecrafts and we want to build them fast and launch them quickly. We need NDI for each and every satellite. So to introduce NDI approaches and technologies from large series manufacturing, for instance, inline non-destructive inspections, that would definitely be some interest for our industry to feed this in and to get quicker to the results that we need to make sure that the satellites are fit for purpose and we can launch them. Then also very often we have a problem that's now very much material based, that of course we're having so small quantities that we're using that nobody will develop an alloy for us, let's say for space only. And therefore, whenever we need to challenge, let's say, the boundaries of materials, then we always have to think about how we can get the material for space. And there we see, of course, alloys from non-space applications, which which we have to use in the end. And there's still a lot of benefit or a lot of potential to look at other industries like energy, aeronautics, automotive industry, and how to feed in their material. Of course, aluminum, titanium alloys are always of interest, magnesium alloys, but also polymeric materials. We haven't mentioned that here, but just comes to my mind. Polymeric materials, CFRPs, fibers for CFRPs. That's always a challenge for us to get let's say the latest, the state of the art into space industry. Another one is to expand the range and improve the performance and reduce the costs for refractory alloys, which we're using in our spacecraft high temperature propulsion subsystems. There we are always very limited because we are only building very few of these propulsion systems. And so if there is maybe some potential that we thought from applying the manufacturing and the supply chain experience from example, the nuclear industry, but any other industry that is using refractory alloys with a high quality, I think we would welcome here to have some spin in if there are some ideas, some alloys which can improve the performance, and also reduce the costs a lot and the lead times. Then also when we're looking at now more into additive manufacturing and let's say to simplify the manufacturing processes, one challenge that we have is to achieve large metallic structures. Of course, we can do this partly with using additive manufacturing, but at the moment we also explore the use of large castings, which are maybe developed now in automotive and aeronautics applications. So we see a huge potential here as well to spin these in and then maybe combine them with additive manufacturing so that we have a quicker possibility to make large metallic structures. Another challenge is the helium and the availability of helium that we use a lot for testing, especially for testing and qualification of our spacecraft subsystems. And there we are looking for technologies that would go more into helium recovery so that we are not wasting all the helium, but we can recover it and store it from terrestrial industries like the energy or the industrial production sectors. Then another challenge, of course, is to reduce the environmental impact and cost of composite materials. I shortly talked about composite materials already, but here we are more focusing then on the environmental impact and cost as well. And one potential could be to explore renewable resources for resins and fibers for both. Looking here in the sports industry, motorsports industry, but also automotive industry, where we know that there's already some projects going on to use renewable fibers, for example, but also resins. And then another maybe more in the future, not directly now, but in the future, we are thinking about servicing our spacecrafts as well when we are talking about servicing the satellites around the Earth, but also when we plan to go to Mars or any other destination, then maybe we are building the spacecraft in orbit, and then we also have to service it maybe in orbit. So we're looking here at strategies, methodologies to make it easier to maintain, looking already at maybe at the design and also looking at how automotive and consumer goods found solutions to already in the design, look at maintenance and servicing the structures that we build. The last slide, there we have the other way around. There's one potential that we see from space industry that could go into non-space industry. And this is definitely supporting the emerging hydrogen economy. So we have a lot of experience in tanks, piping, insulation for hydrogen propulsion systems. A lot of our launchers are flying with hydrogen and oxygen as a propulsion system, propellant system. So I think if there is any interest, we know that there's a lot of interest from the aerospace industry. There we have already some connections and some requests. But I think for all other industries who are interested in building up hydrogen storage, hydrogen transportation applications, I think that's something where we could maybe give some relevant information to them in the end. Yeah, and that's the next step. That's basically ESA Spark funding. One of the things that the brokers are doing. And with this, I leave you for the next part. I think in the end, Susanne will talk about the different possibilities, different opportunities that we have in ESA to get funded and to get several avenues to support the spinning startups.
Thank you very much, Andreas, for the presentation. I think this was a really great insight into the specific needs that ESA has and also gives a broader overview what ESA is looking for. I would now ask the audience to take the opportunity that Andreas is here and ask him any questions that you might have on this. I see there is a first question in the chat from Stefan Utschnik. Which size of cast structures are you looking for? Which aluminum alloys?
Well, aluminum alloys, we're always looking for the ones which are not so much susceptible to corrosion. So if we can avoid 2,000 and 7,000 alloys, it's always welcome. From the size of the structures, that's difficult. I mean, we are looking at for tanks, for example, on really quite big structures. So I don't know, diameters of 500, 600 millimeters.
Mm-hmm.
But we could also think of structures, more in terms of brackets. So bracket structure in this case. I mean, the idea behind this is basically to avoid joints as much as possible, because every fastener that we have to apply is basically weight. And if we can do it with a additive manufacturing or cast structure, then we're avoiding weight, and we should be faster as well to assemble.
This is Stefan Utschnik speaking. Hello.
Hello.
Just to underline, we have high pressure die casting machine in house for research purpose, but also for small and medium series, and also are working on a process which is called semi-solid casting, which is in a thixotropic or 70% liquid and 30% already solidified state, which allows for very thin but still very pore-free components. And typically you're casting some kind of aluminum silicium alloys, so typical cast alloys, not 2 or 7,000. It would be possible, but we know it's not the best material for casting. But even if you say you want to go for these kind of alloy, we could A, offer service, and B, support in development. I do not know how much ESA allows for development in these kinds of fields, or just a transfer from up to space technologies. In principle, there's lots of room to think about, and if you say you want to investigate different kinds of geometries, it is possible to do this. I think giga casting and big size casting, as it is now in the media, coming from automotive, it is also for us quite a big topic, and we definitely see that there is a chance also to exploit it towards space. The question is only which would be the routes. Would it be spark funding? Would it be some kind of other funding opportunities via ASAP, as a FFG ASAP call, or GSTP, for example, in order to get in collaboration with you, with ESA, and with potential partners from Austria?
I'm not aware that we have a call out in a GSTP at the moment, but I have to go back to my colleagues to ask if there's something in the pipeline. But definitely, I mean, I think the alloys that you mentioned, it's aluminum silicium alloys, maybe also the magnesium. We're using these alloys for, or part of them for additive manufacturing already. So I think in the end, this should be alloys which we know. I mean, the focus, of course, in casting or in the products for us is then to be as much defect-free as possible. But that's, I think, for everybody, something that everybody wants to achieve. And I think, we ourselves, that's why we had the idea on the slide. We have to look more into this again, because I think casting can be quite fast. And at the moment, from my perspective, my personal perspective, we are machining too much. We are machining too much away from, let's say, we start from a block and then everybody machines very fancy machining algorithms, which we can, of course, avoid if we're using cast materials. Of course, we're avoiding this already when we're doing additive manufacturing, but I think, that's where the idea came, to look at cast materials as well again, and try to feed this into space industry.
Yes.
That's definitely a big interest from our side.
Okay, so maybe we can somehow close the loop via Brimatech or Ms. Katzler-Fuchs. And the other point I would like to propose is that we are also currently working on a titanium forming process, which allows to replace the standard incremental sheet forming by actually a standard forming technology, which allows us to deep draw titanium with a very at very low energy, 60 to 70 millimeters, which is also currently under patent evaluation. And already this we develop with aeronautic industry partners. So that would be one very, very potential and maybe interesting to the ESA.
Yeah, definitely as well. So I think, if we can connect,
I will connect the both of you so that you can discuss bilaterally.
Yes, I think that would be much appreciated.
Okay, thank you.
Thank you. So the next question is, do you have interest in certain materials in LPBF, and which would that be?
What was the abbreviation LPBF? What do you mean with this?
Alexander Eigner, could you please clarify what this abbreviation means?
Laser powdered fusion.
Laser powder bed fusion.
Powder bed fusion.
Powder bed fusion. Yeah, I mean, on this topic, I think we had already a call out. we're always interested in the development of alloys or of powders dedicated for additive manufacturing. I'm not sure if there's at the moment a call out, but I remember that we had already. We're doing a lot on powder characterization and powder development as well. So yeah, I mean, if you're interested in this, or if you can offer something there, I think I would connect you with my colleagues from additive manufacturing, and we can see where we can get a spin in, maybe, or something like that.
Perfect. So Alexander, please just write me an email that you want to be connected to Andreas Tesch, and I will do that afterwards. I will just type my email address in the chat just to make sure that everyone has it. Perfect. And then there is another question from Silvia Kienberger. Which are the top use cases of, I don't know what you mean, aluminium or artificial intelligence?
Artificial intelligence, most likely, yeah.
Okay.
I guess. I guess artificial intelligence. It's not.
Yes,
not...
thank you. This is right. Yeah. Artificial intelligence.
Yeah, artificial intelligence. We are exploring ourselves at the moment. I think we are looking at in several directions. One, of course, is which is, I think, the main focus at the moment is really to introduce artificial intelligence in the manufacturing processes, be it NDI, where we want to have artificial intelligence to quickly give us the results, and not every, let's say, human people to look into CT scans, but to let this be done by artificial intelligence to look for the defects. But also in terms of data exploration for on ground, but also I think in space in the future we will look a lot in artificial intelligence, for example, for exploration missions where you want to have some. I mean, of course, we are looking at the data now as well, and we have data handling systems on board, but they will in the future for sure work with artificial intelligence to be more effective in the end. So this is but yeah, let's say artificial intelligence, digitalization, these are two streams where we are focusing a lot at the moment, and basically in all different areas, be it data handling, manufacturing processes, scanning of test data, yeah.
Thank you very much. Is it possible to provide an overview of use cases you are tackling and funding of support?
Yeah. Also, there I can connect you. I can connect you with one of my colleagues who is focusing on this, and for sure he has a nice overview and also a lot of ideas which you can discuss with him.
Thanks a lot.
Silvia, please write an email to my email address. It's in the chat, and then I will connect you to Andreas, okay?
Thank you very much.
Okay, so the next question from Fabian Kappmeier is if it is possible to get more detailed information ESA needs on dedicated specific topics which have been presented today.
Yes, I mean, in any case, all of the competence domains, for example, have a competence leader, and there we can always connect you to the competence leader, and he can give you more details of this competence domain if you want to focus on one competence domain, for example. That's for sure easy.
Fabian, I would also suggest to keep in touch by email. Let me know which competences you're specifically targeting, and then I will connect you to Andreas, who will be
reconnecting you to the next
exactly
competence domain leader. Yeah.
Exactly. The next question is from Benjamin Losat. Have you tried 3D printed sand casting models for big parts?
Yeah, I'm not sure. You mean printing sand molds for casting in the end? I think we have not yet done this. I mean, what we have done, maybe you're aware of our Regolith printing demonstration. So we have done something there already to demonstrate that we can built on the moon, basically with 3D printing. We could build a whole small moon village. So in this case, we have some experience already, but for molds as such, not aware. But of course, that would be interesting, especially combined maybe with the casting approach. I think that could be very, very, very interesting to see how complex you can build sand casting molds with 3D printing in the end. Yeah.
Benjamin, also here, if you have more in detailed questions, just let me know by email and I can connect you here.
Okay, fine.
The next question is also from the next speaker, Hubert Mitterhofer. What is the focus for lock and release mechanisms? Weight, cost, robustness, optimization, or also other aspects such as, for example, new approaches?
Well, you named all of them already, but definitely I think we have to look at new approaches and see how we can get them. I mean, robustness is always a topic, but most of the times this is basically achieved in terms of cost for weight. So, of course, if we can have a new system which is similar reliable or even more reliable than the ones that we have at the moment with less weight and less cost, that's definitely something we're always looking for.
Okay, so that was already the perfect introduction for our next speaker as well. So thank you all for the questions.
Stop sharing.
Yeah, then we will readjust our.
Okay. Can you all still hear me well? Perfect. Just a quick administrative info in the meantime. Anyone who wants to receive the slides that were presented today, please drop me a short email to my email address, which I will now repeat in the chat. And then I will send you the slides. I'm not collecting the email addresses here in the chat out of data protection reasons, obviously, but just send me an email and I will forward the slides to you. So then we will come to our next speaker. And the next speaker is Hubert Mitterhofer. Hubert comes from the Linz Center of Mechatronics. And the Linz Center of Mechatronics, we have been working together with them since, I would say, 3 to 4 years now, because they wanted to spin into space and were very active in that domain. And they succeeded in doing so in the last 3 years. And he will now let you know what their experience were. We'll let you know some do's and don'ts, and also what you can expect when working in the space domain. So Hubert, thank you very much for being ready to present your insights with us. The floor is yours.
Absolutely. Thank you, Susanne. Thank you for the introduction. I'm sharing my screen and hope that you can all see my screen and hear my voice. Is that good? Okay, thank you.
Yes, perfect.
So I will use the next around 15 minutes to tell you a little bit about the point where we started from. So some info on LCM and why this spin-in strategy was interesting for us. Then give you a short overview about 2 projects that we have conducted for and with ESA. And I'll finish with a couple of lessons learned. And of course, I'll be happy to take your questions afterwards. Now, let me start. Okay. Who or what is LCM? It's the Linz Center of Mechatronics. Our main mission is the transfer of technical knowledge from academia, from scientific processes to industry, to really help our customers and partners to bring new technology into products and to the market. As such, we're active. Don't worry, I'm not going over every detail. Just so you know, the ways of activities that we offer to our partners and customers. Really, that's starting from the first ideas, feasibility studies, and so on. The classic development process, prototyping, testing, supporting the validation, certification, down to the product, and really supporting our customers in the process of bringing products to the market so they can earn money to pay us. So it's quite simple, actually, and we're doing this for many different fields. See here, many of them is not even complete. From, of course, automotive, logistics, consumer electronics, medical devices, steel, chemical, pharma, energy, whatever. I'd rather say, except for weapon system development, which we don't want to do for ethical reasons, we're active in pretty every, or can be active in pretty every terrestrial field. Now, there's also this whatever moves your world. So it's already our idea that we focus on the technology, not a certain branch. And as such, the question came up one day, why not also go to space? And there was a small discussion about it, but the main answer was, why not? So it's just yet another field of activity. And of course, it's, let's say, a little particular one, because as for automotive or medical, there's always special rules, special ways how development works, special features that a product needs to fulfill. And of course, also in this sense, space is specific, but very challenging and very interesting. So let me tell you about two projects. The first of them being a project called Pixel Twins. We closed this, I think, last year or second last year, and it was the idea, or no, even this year. I think this year. It's the idea to combine Earth observation data from satellites with ground truth that you have retained or gotten from IoT devices. How does that work? Oh, sorry. First use case was for smart farming, for instance, getting maps of soil humidity as a main factor of agricultural productivity. And the idea is really to provide a better database apart from the basis that you can get either from satellite data or ground data, IoT data. Right, how can this be achieved? So I'll jump straight to the outcomes. What my colleagues did here is they provided an interface where you can define a region of interest, draw a polygon, typically a field or something. You create the pixels being the satellite data zones. Then you apply your both data sources, the sources that you have from the satellite, depending on, of course, time slot when they were taken, merge them with the IoT data and how that looks like. Second, so this is a video that's hopefully now playing also on your screens. So you see this interface, the user is drawing this polygon. Then we need to select which date we need the satellite data from. We get the pixels. So you see here actual real satellite data. And then there's a lot of additional data that can be merged with this data coming from IoT devices, ground IoT devices. You see them marked as these black spots. And then there is different ways of merging these data. Here it's a classical interpolation. If this is so reasonable for that use case, I'm not going into detail here, but you see that the map was altered, that the data has been merged, and that overall a better data set was created. Sorry. Okay, now the second use case, smart photovoltaics. Are you still seeing my screen?
Hubert, no, you're...
Okay, yeah, I got the message that this was interrupted. Now you should see it again.
Yes, not in
In present,
presentation
yeah.
mode, but
Okay. Now you should see it in presentation mode. True?
yeah, perfect.
Yeah, okay. The second use case of Pixel Twins was on smart photovoltaics with the very same idea, now applied to the solar radiation and additional data from clouds, from, of course, the daytime, the geographical position, and so on. Again, same idea, to have an interface where you can draw your region of interest, create the pixels from the satellite data, and then apply and merge both data sources. Again, a short video where you see Scharinger Weg close to Linz, which actually means that the data comes from a colleague of mine who supplied his photovoltaics data that he had as ground truth available. Now you see how everything is selected. And also an interpolation would give following result, as you see in the screen. And the map is maybe not the main benefit here, but really this prediction here that you have on the bottom right, the theoretical curve, then the curve that you get when you look only at the ground data, and then the data that you, or the curve that you get from satellite data plus additional data like cloud source, like clouding, and then the, let's say, better product forecast data for your photovoltaics production. Okay, let me jump to the second project, which was called MagBreak 2. The target here was to design, or let's say, to hold an electric motor in its rotation position, in its angular position while it's off. And the requirement was to have very low or zero idle power consumption and to establish the whole thing without mechanical contact, because as you all know, mechanical contact in space can be problematic. This was part of an ARTES funding program. Now, the motivation behind is quite clear. There is a lot of electric motors and rotary actuators used, especially in satellites, all different types of spacecraft to orient your pointing mechanisms, your solar arrays, etc. And the critical requirement is always the unpowered holding torque. And if you need more unpowered holding torque, the classical solution is you take a bigger stepper motor. Even if you don't need the torque capacity of that motor, you just need it for the unpowered holding torque. Or you can also add an additional gear stage. But of course, both add system size, weight, and costs. The alternative solution is to use a smaller motor, just big enough to actually drive your load, plus a brake. And I'll not go over all images, just to show you first step, a lot of engineering work. So we did topology studies, simulations, mechanical simulations, electromagnetic simulations, thermal simulations, mechanical construction work. Then finally, towards the breadboard manufacturing, and then an extensive testing phase of that breadboard. And we came out with this result. So we matched this to an existing very common stepper. We matched it that the size would be, consistent to put the whole thing in one cartridge. And we were able to, first of all, demonstrate the principle successfully and also fulfill already most of the requirements, except for the weight requirement and the redundancy requirement. Then there was the next project phase, towards the engineering model, more engineering work, of course, more simulations, better mechanical constructions, EM model construction plus manufacturing, and again, extensive testing. And what was the outcome of this was the results of the EM, also fulfilling the weight requirement and the redundancy requirement. So after all, we really ended up with a magnetic brake that was able to provide sufficient holding torque. So the required holding torque was 120 milliNewton meters, we were able to exceed this. We were able to also, hold the dimensions, the electrical interface, the thermal range where this was tested. And that was mainly the outcome of this product. At the end, of course, as it is usual, ESA General Director, Mr. Aschbacher, came by to congratulate us on it. In all seriousness, this is of course not the standard, but we had the chance to present this project also at the Industry Space Days, and Mr. Aschbacher just walked by, and it was a good opportunity for a photo. Then here you see the demonstrator here, where you can turn by hand a shaft and then either lock or unlock the brake to really give you this feeling what the device can do. Okay, so some lessons learned. First of all, there's a lot of abbreviations in space. There's, as you see here, really a lot of different ones that you get used to by the time. And in the beginning, this can be quite confusing. So don't worry, I'm not going over them in detail, but this was really one lesson learned. And a little bit more serious now, I'll really like to give you 10 serious reasons why, what I think that we learned from our space project. First of all, project officers are a great idea. We were lucky in both of these projects to really have very good project officers that guided us, that gave us explanations to the abbreviations and also the insights behind it, really connecting us with the relevant sources of information, explaining us how the different reports, the different project phases, etc., should be done. Because I think ESA projects and generally space projects, they follow their own rules, but in my understanding, once understood, these rules are quite consistent. So it is a little special, but okay, every field is special, and yeah, that's how it is. Don't be afraid of contract work and ESA Star. So it's not the Death Star after all. Sorry for that comment. It was just so evident. Yeah, ESA Star, if you're familiar with the European Union funding portal, then it has some similarities. It doesn't always work so intuitively, but you get used to it. And yeah, it's these funding portals, it's sometimes can be a nuisance, but in general, they do what they're supposed to do. ESA wants to encourage you to further innovate after a project, not to steal your ideas. This was particularly for the second project where we had this idea on how such devices could be built before the project. So we communicated this and how does it work with patent and everything. And we also patented this principle. And ESA was very permissive in this sense. The only requirement is that all the project results, of course, can be used by ESA. But in general, we have the strong feeling that there is this push to really make something of the results, to carry this on, to further innovate, and not in any kind to, not take this away from you and somehow cut you out. It's really a very, very fruitful cooperation, I would say. In this sense, ESA may also help you. Of course, also point 4 depends on the project or the program, I would assume, but generally, ESA doesn't steal your ideas. ESA can also help you to set contacts for further dissemination and application, also business application, of course. Also, of course, depending on the type of program or project you have been doing. But generally, we found this very helpful. We have been in contact with several space players, so to say, to see if especially the magnetic brake can be of use for them. And there is some follow-up activities. Unfortunately, not allowed to tell you about them in detail, but there is some follow-up, and we see progress here. Generally, space projects allow to expand your range of activities based on your competences. So in our case, our competences were quite clear in the field of electric machines, magnetic bearings, electromagnetic actuators. We knew what we can do, and we knew in which fields we're active. And in that sense, Space Authority or ESA offered the opportunity to apply this knowledge, these competences to their challenges. Then, of course, space components need very high efforts in R&D, in manufacturing, in testing, but they also allow, let's say, reasonable pricing, in the sense that just looking at the efforts and the invests necessary to create a space product or a space service, this may be quite high, but on the other end, you're also not selling it for €9.90. You know, it's of course these efforts somehow need to be within the price then at the end of the day, and that's what we also learned. ESA projects have high visibility and provide interesting networking spaces. So first of all, the visibility, if your communication colleagues do a post about you successfully concluding an ESA project, this is always a nice thing. You know, space is still space, it's still rocket science, you know. So it automatically creates high visibility, and also concerning everything that I've said before, you know, the different or maybe a little particular rules, the precision required, the competences necessary, it also reflects on the companies active for space, that they're proper companies, that they know what they're doing, that they can also handle administrative challenges, that they're kind of stable. So I think it's a very positive image that comes with it. And concerning the networking spaces, especially the industry space days or final presentation days, this is also really an interesting opportunity to get to know players, other players from space, other spin-in players, and generally to network. And last but not least, networking is good, but networking does not replace your competence. So that's something we knew or we suspected. And I think it's never, as for any other funding, never a good idea on just to you know, rely on good networking and making sure to somehow get an arrangement. But it's the competence that counts, plus of course good funding proposals. Okay, so in the beginning I said why go to space, and the reason that the answer was why not, and maybe we can one day also have our coffee on Mars, or somehow have a little part of LCM, or little, let's say, share that we have in some future space missions. That would be really great if we can actually come up with flight hardware and provide this. Okay, so thank you for your attention, and I'll be happy to take your questions if there is any.
Thank you, Hubert, for the super great insights that you gave. Just a comment, your astronaut had a NASA flag on his shoulder, so maybe you could replace this.
Yeah, you know what? The funny thing is, I created this image using AI. This is not a photo or a photorealistic animation. And this is actually not the NASA logo, because what I tried to get rid of it, but I was successful. So they always the artificial intelligence I used for these graphical things, they tend to distort logos and names and so on. So, yeah. But it looks very much like the NASA one. I agree.
I think we have some questions here. So I have a hand raised. Anna.
Yeah, hello, I'm Lily. Actually, just still could not, you know, like this name fiasco, I still could not change it because I'm Lily Anna, and that's why I'm using for that Anna. Yeah. So basically, I'm coming to my question then. So are you making some services, because I'm very well aware of this magnetic brake technology, and also I talked with the representative person of the technique, and my question would be that are you taking also commissions that so kind of to integrate this technology into our satellite system, even if it needs to be adjusted, for example, in size, because in our system, so for nano satellites or microsatellites or smaller size satellites, that not necessarily would fit in. But we definitely could see a very relevant usage, yeah, for our system. And that's the question if you're doing also.
Absolutely. Absolutely. This is, this case was, so this design here, we did to match the Safran, I forgot the P51 or something, a certain stepper motor to really match it in the circumferential or diameter sizing. But all activities that we had afterwards with different space players, not everything ended successfully in a collaboration towards a product, but in all the activities we had there, we needed to resize because, of course, always the actuators are different. The space available is different. There is different requirements that sometimes this redundancy is handled in a different way, not requiring to have really redundant double coiling inside here, for instance. Or of course the connecting points, how this is then attached to the motor or relevant housing. So the question is absolutely yes, we're fully prepared and also doing this to adapt this to the respective requirements.
Perfect, thank you very much. So far then I understood it correctly. Then as soon as we are at the stage with our prototype, then we can just simply contact you or the team, and then we can discuss that.
Absolutely, absolutely. So within the project, we did the BB and the EM, and in one of our follow-up activities, we also produced flight hardware. This is tested as flight hardware, but did not fly yet. So let's hope one day it will.
Yeah, fingers crossed. Thank you very much.
Thank you.
Are there any other questions to Hubert? Hubert, if you agree, if someone does not understand ESA project rules, I will connect them to you in the future.
Yeah, I will ask you then.
Yes, one question from my side. Thanks, Mr. Mitterhofer. Did you actually now run this R&D project and also your research out of LCM? Or did you also some kind of now think into going for a spin-off or a spin-out of LCM in order to be able to commercialize your new IP?
Thank you for the question. It's a really interesting one. We did have a discussion if a spin-off or a spin-out would be reasonable, but at this point, the industrialization or further activities are driven closely together with this company, IIES. Behind this company name, there's the name Gregor Puchhammer. You may know him from other activities. Yes. And he's also very active in this, and we're going in that direction together. So we thought that it's maybe too early to really, build a separate company for this, because you need the perspective to really have also some economic income and to live as a company. But for the moment, the constellation is sufficient for driving the following up the opportunities that we see. If maybe in later stages this becomes let's say gets to a different level, then we may think of creating a separate company.
Because now you are in the R&D stage. At some point, this development needs qualification, reliability,
yes,
warranty. So is this then Mr. Buchhammer in this engineering services who will then do this, or who will take these responsibilities? Also for us, it's always a topic. It's nice to go for ASAP and GSTP and ESA projects, but at a certain point you want to bring your knowledge into commercialization, either by a project partner or at some point you think about, making a spin-off and taking all those steps by yourself, which needs a startup funding or startup grant of money in order to then make it to the commercialization.
Yeah, I think that so for the moment this question is not clarified, but I see 2 points in this aspect of creating an additional company. One is clearly a liability issue, and the other is, let's say, the focus of activities that this new company would have very clearly set, of course, on pushing these opportunities or following them up and trying to bring this to the market. But up to now, both questions were able to be handled within this loose collaboration, let's say, between the two companies. But if hopefully maybe this one day changes, that there is the necessity to provide higher liabilities, meaning also higher business chances or business opportunities, then this question will certainly be rediscussed. And at that point, I cannot look into the future how our management and how IIES will decide this, but let's say there's some thoughts about it that we already had, and let's take that step once we get there.
I know.
Hopefully.
Okay. Thank you.
Thank you.
All right, there are no further questions in the chat, so I would propose to go to the final presentation. Okay, so after my two speakers today, I hope you're, first of all, full of new ideas that you could bring to space. And second, you're very motivated by Hubert's success story, how you can spin into space. So now the last question is, where can you get support to do that? And I will give you an overview on support activities that we provide here in Austria and where you can get funding for your ideas. So basically, specific programs that have been applied in Austria. So these are programs that are specifically targeted from ESA, but also the Austrian Space Applications Program. So this should be really a basic overview on specific funding opportunities here in Austria. Of course, there are a lot more of funding opportunities for space projects, but these are the ones that are really or have a strong focus for Austrian companies. So the first program, and I think it's also here in space, also the oldest program. I think now we have the call number 18 or something. So it has been implemented in Austria for more than 20 years. Is the Austrian Space Applications Program, ASAP. We also have an ESA Business Incubation Center here in Austria. We have Spark funding in Austria. We have the newly established ESA PhiLab, and we have a program called Prepare4Space, where you can also get specific support. But let me go into more details of the single programs. So the first thing I'd like to introduce is ASAP, the Austrian Space Applications Program. It is implemented by the Austrian Research Promotion Agency, FFG, the FFG ALR. And the objectives of ASAP are really to develop space technologies which are innovative, and to also spread these technologies to other sectors here on Earth. ASAP is also addressing the usage of satellite data, so any downstream data, such as, for example, Earth observation, navigation and positioning data, or SATCOM data. It very much focuses on international cooperation. So even though it's an Austrian program, you can include international partners in your project up to a certain budget limit. And of course, the the last but not least objective is to expand Austria's space industry. So the aim is really to have more companies, more research organizations working for the space domain. Some practical information. It has not been fixed yet, but the next deadline for ASAP is expected in spring 2025. So usually there's a yearly call where you can apply for projects. A typical project size, so this is really just a rule of thumb, could be around 500k euros. It can be anything from, I think, 100, 200k euros to even more. But just to give you a very rough rule of thumb. ASAP usually has three key focus areas. So the first focus area is really the usage of downstream data, as I already mentioned. Then there is a strong focus on science and space exploration and on the development of upstream technologies. And usually they support 4 different project types. So cooperative R&D projects where you together with some partners can hand in. Then they also have exploratory projects, which are usually smaller projects, but they, for example, a feasibility study, they prepare larger R&D projects afterwards. Then there are also individual industrial research projects and oriented basic research projects. Then the next funding scheme I would like to present is the ESA Business Incubation Center. It's a startup incubator basically that supports startups in turning space technology into viable business. In case you are a young company, a startup company, you can apply for ESA BIC. The services offered you can get up to 50k euros in funding and technical support. So the technical support is provided by ESA BIC itself, but of course there is also ESA standing behind that. You can get access to ESA expertise, to labs and facilities. Of course, if you're admitted to ESA BIC, you can also use the ESA logo, which is for a lot of startup companies a big asset. You get business development and mentorship support. And of course, you have access to the very large network, which consists of a lot of contacts to industry, to ESA, but also to the over 1,700 other ESA BIC startups that exist around Europe. In Austria, at the moment, we have 3 locations for ESA BIC. In Styria, there is the headquarters for ESA BIC, in Lower Austria and Salzburg. And I have also copied you the link for the ESA BIC in case you're interested in that. I'd also like to mention, if you're a young or startup company, but do not know yet whether you have a space connection that would qualify you to apply to ESA BIC, just contact us and we will guide you and help you and see with you together whether there is a viable space connection for you. The next program we have is ESA Spark Funding. ESA Spark Funding is targeting technology transfer, which means the transfer from technologies between space and non-space sectors. So you can either transfer an existing space technology to a sector on Earth, or the other way around. You can have a nice technology where you think that this technology could have an impact into space and try to transfer this technology into the space domain. The typical project size that we have in ESA Spark Funding are projects of up to 50,000 euros in funding with a duration of around 12 months. And the next call will be issued in summer 2025 with a deadline in autumn of 2025. I have pasted you the website where you can find all the information for ESA Spark Funding also in the slide here. Then there is, as I mentioned before, the newly established ESA PhiLab. The ESA PhiLab is part of the space hub that is now developing at the Vienna airport. And the ESA PhiLab really is an excellent center for the development of upstream technologies that are fit for new space, with a very strong focus on the commercialization and the industrialization of these upstream technologies. In the first two calls that we had in the ESA PhiLab, projects were allowed with a funding of up to 500k euros and a duration of up to 2 years. And the next call is expected next year. I have pasted you also the link for the PhiLab in the slide. Maybe something that I would like to mention in addition, the PhiLab differentiates from other funding streams, as you will be part of a community there, where you can get a lot of support throughout your project. So as I said before, you will receive funding, the PhiLab, but the PhiLab also offers very extensive support and coaching in the fields of business, of tech, of IP and sustainability. If your project is admitted to the PhiLab, you will get a workspace at the Vienna airport. You will get access to the network and also access to a lot of partners that we have in the PhiLab that have modern labs, maker spaces, and other specialized facilities. So as you can see, there is a lot of funding opportunities when you have space ideas. One that sticks a bit out of the others is the ESA OSIP. ESA OSIP is not the dedicated Austrian funding scheme, but ESA OSIP is a very nice tool in case you have an idea which you think that is relevant for space but are not sure yet. Because in ESA OSIP, you can submit any idea that you have for a spin-in for evaluation, and there will be ESA experts from different departments that will evaluate your idea and give you feedback on the idea. And if they deem that the idea is relevant for ESA, they will also guide you to ESA funding schemes. So this is really a nice tool to get feedback on ideas that you have. You do not need any prior knowledge of ESA programs. You do not need to deal with ESA Star, as Hubert mentioned before. So OSIP is a bit of a lighter platform where you don't need so many time to get accustomed to it. And it really is a simplified process. I have pasted you the link to ESA OSIP here as well. So a lot of information, a lot of programs and paths that you can follow. Maybe now you have a lot of question marks. So if you are not sure which path you want to go, we can support you. So just contact us, write us an email. You can either contact my colleague, Aigerim, who is in the meeting here, or myself. I have posted the 2 email addresses also in the slide. Just contact us and we will try to guide you to the jungle of different tools that are available. Our services are completely free for you, and we also have the opportunity to do a one-to-one support for you, so you do not need to disclose your ideas in front of any others, so you can really come to a safe space here.